Today we're going to talk about acid etching, what it is, how it works and how to do it. Hi there, thank you for joining me. My name is Marcus, this is Reeves Electro and you're watching the Friday Finish. A little bit of housekeeping first. If you haven't subscribed, please do so. I don't know where the subscribe button is these days, but you know the drill. You know the drill. It helps my algorithm as well. I'm trying to build this channel up a little bit, so every like, every subscribe, every comment is very much appreciated. Thank you. Right, let's go on today with today's subject. Oh, I can't speak today. What's going on? Acid etching. What is it and how's it done? Acid etching is a little bit of probably a misnomer actually, because very often you don't use acid to do the etching, but it kind of started with acid, so I guess that's where that's come from. It's chemical etching, but most people know it as acid etching, so that's kind of where it's stuck. How does it work? Okay, so that's what it looks like first of all. It goes dark where it's exposed to the abrasive chemical, the acid or whatever it is you're using. But where it's not exposed, you have to put a mask on here. So that can be screen print ink, that could be laser toner, it could even be just cut vinyl. I think we call it press and peel over in the States. And what happens is the light areas on here are protected from the acid with what's called the resist or the mask. So you drop it in the acid and the dark bits get eaten away, where the bits that are protected are left as the original finish. That's how it's done. I'm going to talk about basically three things: different types of mask, different types of acid, or what we call mordant. I may use the word mordant a fair amount, and that's the etching medium, and a little bit about how best to finish these things once you've done them, and a few considerations at the end about how you approach it and what process you might decide to choose. So let's start off with the masks, the etch resist. There's three basic types. There are a few others, but let's just go. I could be here all day otherwise. So as I mentioned before, there's cut vinyl, great for really bold graphics and things. It falls quite short if you want to start doing smaller things. So just be careful, and it does eat underneath as well. The acid does tend to eat underneath the vinyl quite quickly, so sometimes if you go small with your image, it gets even smaller because the acid kind of eats underneath it. So but it's good, it's cheap, it's very easy to do, and it's pretty straightforward. So if you've got some big things that you want to do, then that would work well. Laser toner is probably the most commonly used. Laser toner, how does that work? Well, the laser ink is acid resistant, so what you do is you get a special piece of paper. Some people use magazine paper, some people use, I prefer the wax paper from the back of stickers. You put your design through a laser printer, and then you transfer that image across to the enclosure. You can use heat, or you can use cold transfer using acetone and rubbing alcohol. Again, I've done a whole episode about that a couple of years ago. So if you want to check out transfer stuff, it's there somewhere. I can't remember what it's called. I'll try and link it up if I can be asked, if I'm honest. But scroll down, you'll find it. The paper yeah, it does make a difference. Magazine paper doesn't seem to work very well for me, but the waxed sticker paper is great for that. So the hot transfer way is just to put an iron on top of it for a while and let it cool, and then peel it off or wash the paper off. It's quite fragile. Once it's on, it's quite fragile, so you need to be careful. It works well with the acid though. And then there is screen printing, which is what I do, which is great for large numbers, not so good for small numbers. Go back and have a look at the last week's episode about screen printing. I didn't really do much about screen printing etch resists though. So you use a specialist screen printing ink that is used for usually making PCBs. So talk to a screen supplier and find out, you know, their ink. I would love to recommend one, but I have a great big 5 litre can that was passed to me by a friend with no label on it, so I don't know what it's called. I don't know who's made it, so unfortunately, and that 5 litre can is going to last me a long time. So yeah, look for PCB etch resist screen print ink. Something will come up. Make some phone calls, do what you need to do, and they all have pretty much the same result, you know. Okay. The one thing at this point, when you're putting your etch resists on, what you have to consider is, now I fully immerse my enclosures completely in the Mordant, okay, which is why I paint the insides so that they don't get attacked by the various different types of acid. If you just want to put a graphic on the top and leave the rest as it is, you'll need to mask it out with something, and for finer details, using nail varnish works really well, but tape round nail varnish, and then you can get away with a shallow pool and just drop it in the shallow pool and just have it etch away at the image part. But I used full immersion because it's also a bit quicker, and I just love how cool the patina comes out on it. It's always different, always comes up different. So okay, so let's talk about the different types of mordant, different types of acid that you're going to need. There's kind of 3 categories. One is the kind of high risk. The top category is high risk, hard to dispose of, and you know, just a bit nasty really. So you've got things like nitric acid, caustic soda, and sulfuric acid, which are used. All of them give off horrible fumes and can be very volatile. If you mix them to be fast, then they will be they'll be really aggressive at reaction, lots of fumes, lots of heat, and quite dangerous. Okay, they give off some really quite dangerous and possibly even explosive fumes. So I've always avoided nitric acid, caustic soda, and sulfuric acid because it's just, for me, it's too much risk. I don't like dangerous processes, especially when you're doing lots of them. So, but they are, I mean, caustic soda is about the cheapest of the cheap, but you know, you can be etching something for hours with that. So it's it depends on what you're doing. If you're making a pedal for yourself, and you know that's it, then probably the way to go. If you're like me, you see here, there's 24 enclosures altogether there. You know, 3-4 hours of time with caustic soda just isn't going to cut the mustard. So it depends what you need from it. Then there's ferric chloride, which is fairly toxic. It won't burn you, but I wouldn't want to get it on my skin. I definitely wouldn't want to swallow it. And that is again difficult to dispose of. So and it's messy. It stains everything it touches yellow: plastic, metal, wood, your skin, your clothes, everything. So I used it for years and years and years, and it can be quite volatile as well, and it produces a lot of heat very quickly. So I used that for probably a decade, and then I switched probably about a year ago to copper sulfate and salt, and that is cleaner, minimal fumes, but it's still, I still use an extractor fan, and it's a great etch. But the one thing that I would say is that it does expire. The solution itself does expire quite quickly compared to some of the others, like sulfuric acid, and caustic soda, which you can carry on using ad infinitum, really. So that's my choice. What I would say is, whatever you do, make sure you have really good extraction, really good fume control. You know, if you can do it outside, just be careful, but don't do it inside and think, yeah, this place is, this is a big enough room. No, you need extraction as well. As far as what solutions you need to use of all of those, I could rattle off a load of solutions now, or dilutions, should I say? Sorry, what dilutions you need. I would just do a bit of research yourself. You're going to need, I can't cover everything, so you're going to need to do some research. So I would do a bit of research and research some of the different types of Mordant and find out what the dilutions are and experiment yourself, because it seems that everybody's attack is slightly different, and everybody's needs are slightly different. So there will be quite a few waste enclosures before you start getting it right. You know, hopefully not too many, but it's a steep learning curve. But once you've learned, it is just the, I love acid etched enclosures. I think they're brilliant. How would you finish them? Clear coat. I would advise you get them clear coated within 48 hours of etching them, because with cast enclosures, what you tend to find is that they get a kind of salty, chalky kind of oxidization on them, which repels your and looks a bit crap, to be honest, even when you've put your clear coat on them. So I would say, you know, get them dried, get them washed, and then get them clear coated as quickly as you can after that. Just an acrylic clear coat will do fine, and that's that. As far as what you need, as far as equipment is concerned, you're going to need some decent sized plastic baths. I use these. What I typically drop the I use as a bath for the acid. These are my measuring jugs where I measure out the acid. It's not acid. I still call it acid. My copper, sulfate and salt. Then I've got two slightly bigger ones which are full of water for washing out. So when I think it is, I've got gloves on, always wear gloves. Forgot to say that. Always wear proper gloves. Take it out, put it in the first wash and check whether it's got to the point you think it's a good enough etch. Clean it off, then put it in the second wash where it's cleaner water, and you can leave it in there. If you're doing subsequent etches, if you're doing more etches, you can leave it in that clean wash, and then come back and you've got, you know, 4 or 5 you can go and clean and finish. And that's pretty much it. Sounds simple, doesn't it? But it's a very, very steep learning curve. Like I say, please wear gloves, please wear protective glasses, please have adequate extraction, and please be mindful of how you dispose of these chemicals. I have to pay to get mine disposed of because I use quite a lot. Make sure you don't tip it down the drain, because it's everything from actually melting your drains to being harmful to marine animals. So yeah, there we go. Short and sweet, always a little bit rambling. Thank you so much for watching these. I'm getting some great feedback on these, which is really appreciated. So if you do have anything to say, whether it's positive, whether it's a criticism, whether it's a question, whether it's some extra information about what I do that I've missed, please drop it in the comments below, and I will do my best to reply. Thank you for watching. My name's Marcus. This has been the Friday Finish, and remember, keep it fuzzy.